Let's take a look at polynomial division by a monomial. Now there's a property goes along with this. I'm not going to really use a property. I'm going to talk about an easier way to think of it. But the property says if you got x to a power over x to a power, like x to the m over x to the n, then you can subtract the exponents. So you got x to the m minus n. Well, there's an easier way to think of it than that, though, and we'll take a look at these examples. Okay, so we got 5x to the fourth minus 15x squared divided by 5x squared. Well, to begin with, whenever you got a monomial in a denominator, single term, then you want to split it up into separate fractions. So I'll put 5x to the fourth over 5x squared minus, and then I'll put the 15x squared over the 5x squared. Okay, let's start with the numbers. 5 and 5 both divisible by 5. 5 divided by 5 is 1. 5 divided by 5 is 1. Now we got x to a power over x to a power. And I told you I was going to give you a simpler way to think of it than this formula. If you got x to a power over x to a power, you subtract the smaller exponent from the larger one. So we got 4 minus 2, which gives us 2. And we're going to have x to that power where our larger exponent was, which was up on top. So we got x squared. Nothing left down below. Okay, 15 and 5 both divisible by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. Now, since these are both x squared, they just drop away. And we're left with x squared minus 3 for our answer. Let's look at our second one. This second example will show that that concept a lot more than that first example. 2x to the third, y to the fourth, minus 3x squared, y to the third, minus 5xy, all over 4x squared, y squared. Let me double check my signs. X squared, y to the third, x to the third, y to the fourth. Signs, numbers. Okay, everything looks right. Now notice we got a single term down here again, a monomial. So we're going to split this into separate fractions. So I'll put 2x to the third, y to the fourth, over 4x squared, y squared, minus 3x squared, y to the third, over 4x squared, y squared, minus 5xy over 4x squared, y squared. And let me double check everything. That looks right. Okay, now let's simplify. Numbers 2 and 4 both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Now here we got x to a power over x to a power. So I'm going to subtract the smaller exponent from the larger one. 3 minus 2 gives me 1. So I have x to the first power where my larger exponent was, which is up on top. Now here we have y to a power over y to a power. So I'm going to subtract the smaller exponent from the larger one. 4 minus 2 is 2. And we'll have y to the second power where your larger exponent was, which is up on top. Minus, can't do anything with these numbers, so I got 3 and 4. These x squareds are the same, so they drop away. Now here we got y to a power over y to a power. Subtract the smaller exponent from the larger one. 3 minus 2 is 1, so we have y to the first power where your larger exponent was, which is up on top. Minus 5 and 4. Now these single variables here, x and y, they're like first power. That's an assumed when you just have an x and a y. So here we have x to a power over x to a power. We'll subtract smaller exponent from the larger one. 2 minus 1 gives us 1, and we'll have x to the first power where your larger exponent was, which is down below. Now here we got y to a power over y to a power. So subtract smaller exponent from the larger one. Again, 2 minus 1 gives us 1, and we have y to this power, y to the first power, where our larger exponent was, which is down below. If you follow that simple rule that I just gave you, you don't have to worry about handling negative exponents when using this setup. You may have to use them in other problems, but you don't have to worry about them in these type. Okay, so the 1 drops away there, so this gives us x y squared over 2 minus 3y over 4 minus 5 over 4xy. And that's our answer.